Okay, so we're going to talk about spontaneous versus non-spontaneous reactions. And this involves the concept of Gibbs free energy. All right, so by the time you're done with this, you should be able to tell me what Gibbs free energy is and how that relates to something being spontaneous and being able to decide if a reaction was or was not spontaneous based on its Gibbs free energy. So what does spontaneous mean? All right, so what sort of things come to your mind when you hear the word spontaneous? I mean, to me, it's, energetic, willing to do anything, just kind of, somebody with a lot of energy, things like that. When it comes to reactions, what it means is that they readily react. All right, they don't need massive inputs of energy. They probably need some, but enough where just room temperature is going to provide enough heat. All right. Really, what spontaneous reactions mean is they just occur naturally. All right, they happen on their own. We don't have to do anything to get them going. As long as you put the chemicals together, they'll react. All right. Some spontaneous reactions can be incredibly fast. Like if you were to take a piece of solid sodium and throw it in water, it would react immediately. Others can be really, really slow, like rust. All right, it can take years for rust to occur. These are all spontaneous because they happen on their own. Even if they're slow, they can still be considered spontaneous. So, spontaneous reactions have very large equilibrium constants. All right? The products are favored much, much, much more than the products. Because of that, a lot of times we don't even bother doing the double arrow. All right? A lot of times you'll just say that, okay, this is going to go to completion towards the products. Or so much of it is that it really doesn't even matter to consider the reversibility of this. The reason why spontaneous reactions exist is because they have free energy to release. Generally, it's in the form of heat. All right, the free energy we'll talk about was something else that it can release it as. But just considering heat for right now, if a spontaneous reaction generally releases heat, all right, it's free energy, is giving off some heat, what kind of reaction are we talking about? Exothermic or endothermic? It's releasing heat or giving off the heat. Yeah. Exothermic reactions are much more likely to be spontaneous than endothermic. All right? It doesn't mean that all exothermic reactions are spontaneous and all endothermic reactions are not. It's just as much more common for it to be an exothermic reaction and be spontaneous. The reasoning for that is Gibbs' calculation for free energy. All right, so Gibbs came up with how to calculate the free energy. So delta G is the change in free energy. All right, we've seen delta H before. That's enthalpy, or the heat released or absorbed. So what does it mean when we have negative delta H? Is that exo or endothermic? All right, it's giving off, it's losing energy, so that's exothermic. T, I hope you recognize as being temperature. And again, you should do this in Kelvin. And then delta S is the change in entropy. We'll actually talk about this in more detail in the next lesson, but entropy is the randomness or the disorder of your reactants and your products. All right? Reactions tend to increase the randomness. All right? So a negative delta H, an exothermic reaction, and a positive delta S, or an increase in randomness, both contribute to giving off free energy. So what that means is that the sign on your Gibbs free energy will let you know whether or not your reaction is going to be spontaneous or not spontaneous. All right, so if you calculate and you get a negative overall delta G, that reaction will be spontaneous, and it's going to go to completion. If you get a 0 Gibbs free energy, that means that your reaction is at equilibrium. All right, so you're not really going to get any reactions because it doesn't want to. It's at equilibrium, it's happy with where it's at. If you get a positive free energy, it's going to be a non-spontaneous reaction, or it may even go the opposite way. All right, so if you didn't write this down on the last slide, make sure you write it down now. This is a reaction or an equation you'll need to know. For most of the questions you're going to run into, just being able to state whether or not, a negative delta G means spontaneous, a positive one means non-spontaneous is good, but here is also an example of calculating Gibbs free energy. All right. Again, you're going to have values. You have to be given these things. But if, say, we have a reaction that is endothermic, right? It's positive. I'm going to plug my delta H in for that, and then I'm going to subtract 25 degrees Celsius is not in Kelvin. All right, so I need to add 273 to that to get that into Kelvin. Should make this 298. So 298 K. And then my entropy is 0.1087. And now let's calculate this. All right, my delta G is going to be 28.05 minus, what did I get? 32.39. All right, so that's going to give me